Good morning, good afternoon, and good evening, and welcome to the Enric Tech Talk, Enveloping Advanced Reactors to Streamline Environmental Analysis. My name is Steve Grabinski, and I'm a project manager at the National Reactor Innovation Center, and I will be moderating this event. Before we get started, I'd like to go over a few items so you know how to participate in today's event. For the best experience, please turn off any VPN or Citrus connections. Please submit any questions by typing the question into the section of the control panel. You may send questions at any time during the presentation, and we will address them during the Q&A session. For any technical issues, please email Cheyenne Odenthal. Her email is in the chat section of the control panel. For any programmatic questions, please send an email to enric@inl.gov. This event will be recorded and provided on the Enric website. Our speakers for today are PNNL's Dave Goodman, Bruce McDowell, and the NRC's Dan Barnhurst. They will also be joined by PNNL's Dr. Phil Meyer, Dave Anderson, as well as the NRC's Laura Willingham. In the interest of time, the panelist biographies can be found on the Enric website, and there is a link in the chat section as we have a lot to cover. Now you'll get to hear from Dave Goodman and Bruce McDowell on enveloping advanced reactors to streamline environmental analysis.
Good morning, this is Bruce McDowell, and I will be followed by Dave Anderson and the rest of the PNNL staff that were mentioned earlier. Today, we would like to describe the development of the plant parameter envelope approach, how it's been used in the past, and what we consider to be lessons learned in these past approaches. We want to describe that adaptation of the PPE approach to Enric's mission. We want to describe how this PPE is anticipated to be used and its limitations in potential NEPA reviews. And we'd also like to go down some of the licensing and authorization pathways and how the PPE could be used for those pathways, particularly for advanced reactor deployments. For definitions, we'd like to start with what is a PPE, what is an SPE. A PPE is a plant parameter envelope. Now, this is a set of reactor and owner engineer parameters, and it's associated not just with one reactor design, but with a suite of reactor designs. What's important here is that it's not just the reactor parameters. In some cases, the owner may have some additional engineered parameters for how they will adapt a reactor to a site. The second is the site parameter envelope, and these are the set of parameters that are associated with the environmental resource requirements associated with one or more reactor designs. Again, this is looking at a suite of designs, not just one design. Now, the combination of the PPE and the SPE, I'll use those acronyms, allows for the environmental analysis of these issues in a generic way. Can you go to the next slide, please? This PPE approach has been used before. It's been originally developed as, by NEI, and you can find a definition of that approach, the more description of that approach in NEI 10-01. It describes how an applicant can use this approach. Figure 1 shows how this approach is used, this PPE concept. Generally, what occurs is the vendor provides a worksheet on their parameters, and you get multiple vendors to provide worksheets. That information from multiple designs is used to create a plant parameter envelope, again with reactor parameters and owner engineer parameters. You combine those with the site characteristics and site information, and that is used to develop an application for an early site permit. And that has been done several times. In particular, this is has been used for sites such as the Clinch River project, the PSEG project, and the original development of the PPE by NEI used a variety of different parameters. For Clinch, there's a listing on the bottom of the vendors that were surveyed to develop their plant parameter envelope. That was at the time Empower, NuScale, Holtec, and Westinghouse. For PSEG, they surveyed ABWR, or the designs were considered were ABWR, AP1000, the US EPR, and the US APWR. The original NEI development was back in the early 2000s, and they looked at a variety of different reactors that were, information was available about at that point. Now, the concept here is that this set of parameters can be used to define what we think of as a surrogate reactor. It's not a reactor that would ever be built. It would be a reactor that would have a set of bounding parameters from an environmental standpoint. You would choose the parameter that, for instance, had the largest land use. You would choose the parameter that had the largest water use, the deepest excavation, the highest stack height. Again, that would not be a reactor that would actually be built, but it would be a reactor that would have it would be a reactor defined by a set of parameters that would have the largest environmental impacts, and that set of impacts would bound a site, the impacts at a site. Next slide, please. Again, this approach has been used several times. Most recently, it's been used for the Clinch River project. Tennessee Valley Authority applied for a early site permit for the Clinch River site. This is a site of the former Clinch River breeder reactor. Picture is shown in the lower right-hand corner. And there had been previous work done at that site for that partially constructed project. There was a 2-year review for this early site permit, and the early site permit has been issued. There's a link here in the bottom of the middle of the page to that ESP if you would like to look at it. Again, the plant parameter envelope was developed using a set of parameters from 4 different vendors. For Clinch River, the total of the plant parameter envelope from a size standpoint was 2 or more modules with up to 800 megawatts electric total output. And that means that any reactor that falls within that set of plant parameters would have already had the environmental impacts reviewed for that site. For instance, a vendor that would want to come in with a 300 megawatt plant would generally fit within that envelope. Next slide. At this point, I'll pass this over to Dave Goodman.
Great, thanks, Bruce. So Bruce has talked a little bit about the past applications of PPEs and SPEs, and I'm going to talk a little bit about how they're being applied now. The slide on the screen here is talking about the NRC Advanced Reactor GEIS, which many of you are aware is ongoing. And we have Dan Barnhurst and Laura Willingham from NRC here to talk specifically about the ANR GEIS, so I'm not going to get into detail on that for now. But what I will say, just very broadly, is that the ANR GEIS also uses a PPE and SPE concept. And there's been a lot of information sharing between NRC and DOE regarding the PPEs and SPEs. And therefore, as NRC has been developing and applying the PPE and SPE, they've been working very closely with Enric and vice versa, as you can see on the next slide. Enric has also adapted the PPE framework. So as we developed the Enric PPE, we attempted to be as broad as possible while providing relevant and useful parameters, like Bruce was saying. In some cases, developing a bounding value is pretty easy, size or water use, for example. In other cases, such as fuel type, cooling technology, or others, it's not as easy to determine what is the largest value. They're all apples and oranges, really. So we attempted to identify broad characteristics that would result in reasonable bounding values. And the work that we've done for Enric is to develop 2 PPEs and SPEs for 2 size ranges. It's microreactors, which were defined for this PPE as single units with outputs up to 60 megawatts thermal, and small to medium-sized advanced reactors with outputs above 60 megawatts thermal up to 1,000 megawatts thermal. And from the information we gathered that I'm going to talk about on the next slide, this seemed like the most logical split. And as we sort of broke down the data, that sort of became clear. So as we developed the PPE report, we relied on a number of data sources. I guess I'll start with number 2, which was the ANR GEIS, which I've already mentioned. That PPE was developed preliminarily by NRC, and we applied that in our work. We also went out to a number of vendors to see what information they were willing to provide to us, and we got great feedback from a number of different vendors, which we really appreciated, as we were sort of asking them to provide us with information for free. But we got a lot of great information back and a lot of information that we carried forward. Where that information was missing or incomplete, we supplemented that with existing information that we received from Enric and Idaho National Lab, work that had already been done. We also did quite a bit of internal research to come up with the bounding parameters, and we have some of our colleagues at PNNL that were the subject matter experts in developing those, and they're going to talk to that in just a minute. And then in certain other cases, there are regulatory limits which sort of made the bounding parameter sort of obvious and easy to derive. So I think first I'm going to kick this over to Phil Meyer to talk about how he derived some of the water parameters that we carried forward into the PPE.
Thanks, Dave. So for the water-related parameters, these included the consumption rate and the discharge rate, the water source, and the discharge constituent concentrations. For the microreactors, the consumption and discharge rates, the PPE values were based on the bounding vendor values, which exceeded our SME estimates. For the small to medium-sized reactors, consumption and discharge rates for the PPE values were based on the SME estimates. And the basis for these estimates included the bounding reactor operating at 33% thermal efficiency, which was considered a lower bound for the set. The blowdown for wet cooling was assumed to be 1/3 of the evaporation. This is consistent with a cooling system operated at 4 cycles of concentration, which was used because it maximizes non-rad concentrations in the discharge compared to the use of fewer cycles of concentration. Also, minimizing the liquid discharge rate is likely to be desirable at INL, and this was specific to INL. The non-cooling process water was 7% of the total water demand, excluding potable and sanitary water uses. This was based on water use of the non-circulating water system for the Clinch River plant. And finally, potable and sanitary water use was 100 gallons per day for each member of the operations workforce. For the water source, we assumed groundwater would be obtained from INL plant services. A new surface water intake and connection would not be required. That's the specific conditions for INL. The PPE for water discharge constituents is comparable to the Clinch River plant discharge, with some consideration of the typical water source at INL. Radionuclides and liquid discharge were assumed to be diluted to meet the regulatory limits at the point of discharge. Thanks, Dave.
Thank you, Phil. So what you can see on the screen here just is sort of illustrative of what Phil was talking about. You can see the few of the water parameters that he was talking about there in the middle. I'm really only bringing this up on the screen just so you can see broadly how we rolled up these parameters into the 2 PPEs. What I'm showing here on the screen is the microreactor PPE. We have a similar set of slides that are ahead for the small to medium advanced reactor PPE. So now I'm going to ask Dave Anderson to talk about the socioeconomic and workforce parameters that he developed.
Hello, everyone. As we know, there's not a whole lot of construction experience with small modular reactors yet, and that required some estimation on our part based on scaling from values that we determined based on small, in the microreactor case, very small combustion turbine plants, small peaker plants. And we made the assumption that these would most closely approximate what the construction effort might be for small modular reactors. And so based on that and scaling the costs of CT construction to 20 megawatts electric provides us an approximation of 20 workers at peak construction. These would be very small pads, as these other plants would be, are sort of indicative of that. Also, for operations, we assume these plants would be very highly automated plants and would approximate natural gas combined cycle highly automated plants and much larger gas plants use very few staff. And so a bounding value of 25 to 50 staff is an operations threshold value that we used as sort of a bounding value for operations. Any larger plants, any array style plants, similar to what was analyzed for Clinch River, would start to more closely approximate our experience with large light water reactors, as there would be many ancillary systems that would be required. And so the construction and operations staffing would scale up accordingly.
Thanks, Dave. So I'm also going to speak, although I wasn't the SME involved in developing this relating to transportation, speaking for Steve Maharis, who wasn't able to be here today. So Steve developed the bounding parameters for transportation for both the microreactor and small to medium-sized reactors. For that, that PPE consists of the number of shipments of unirradiated fuel, radioactive waste, and irradiated fuel, and the associated transport mode, which was assumed to be truck. The number of shipments was estimated based on the surrogate small SMR from the Clinch River ESP, scaled to the power levels, which again are 60 megawatts thermal and 1,000 megawatts thermal, are the thresholds for our two PPEs. And because we assumed truck mode of transportation, that yielded a larger number of shipments than for rail or barge mode. And that was because of the smaller capacity of trucks versus rail cars and barges. And then finally, I'm going to speak to what we did as it relates to source term parameters. And we really didn't get a lot of information there from vendors, and there's really not a lot of information that we could derive without knowing the specifics associated with any reactor. So relating to source terms, because the PPE is agnostic as to specific designs, we calculated fission product inventories based on generalized designs. Once those generalized designs were selected, depletion models were run and radionuclide inventories were calculated. The inventory that was developed can be used to compare designs for individual radionuclide activities, but it does not address combinations of radionuclides. We would only be able to do that when the source term release quantity, mechanism, and chemical form are known. And within the PPE report itself, Appendix C, that contains the reactor source term inventories that we developed organized by radionuclide. So again, what I've put up on the screen here are our two, this is sort of the summary roll-up of our two PPEs. Appendix E of the PPE report that we developed, that's available on the Enric website and is also linked in this presentation, contains a lot more detail as to how we came up with these values, and in certain cases where we were not able to come up with a bounding value, why not, and sort of what we did instead. So I'll go through those real quick just for the sake of time, and also I recognize they're probably pretty small on the screen. and talk about the report that we finalized back in February of this year. Again, I've got a link directly to the report here. It's available on the Enric webpage under the resources tab. A lot of what's in the report replicates what we've already talked about so far here, what the background and purpose of the PPE is, how we went about developing the bounding parameters, includes the aggregated PPE values, which is really what I was just showing on the few slides before, how we think that the PPE could be used, and then finally, we have a lot of the underlying information that supported how we developed that report. So with that, I'm going to kick it back to Bruce to talk about how the PPE can be used and what its limitations are.
Again, when we think of a PPE, we think of a PPE for a quote-unquote surrogate reactor. Again, this is not a reactor that would ever be built, but it would be a set of parameters that would bound the impacts of any potential reactor that a vendor would be, or a developer would be looking at a site. The proposed action in the assessment could include the siting of a surrogate reactor at a DOE site. This is obviously what we were hoping to facilitate, that this PPE approach could facilitate for siting a reactor at Idaho National Lab. The values can be used to assess the bounding environmental impacts, again, prior to knowing which reactors will be sited. In this way, a NEPA review can be completed and be available, and which would streamline the siting of a reactor prior to knowing. So any reactor that would come in later would not have to go through an additional environmental impact assessment. At least that's the hope. There's the PPE really focuses on the unique aspects of the interface between the plant and the environment. There's not every aspect or a parameter for a plant is necessary for an environmental assessment, because there's really no interface, or that interface is not really important to determine environmental impacts. So it does focus on those unique aspects, the ones that Dave showed in the previous tables, and the ones that are listed in our report are those aspects which we think do have a nexus with the environment. Another important point is that PPE is not an assessment of impacts. When we say that the stack height is 58 feet, we are not saying that that's a small, moderate, or large impact using the NRC approach, or making any determination about the significance of that impact. We're just, this is purely a definition of a parameter value. It's not an assessment of impacts. Now, once this if it is used in developing a NEPA review, an EIS, then there will also have to be a follow-on NEPA review of some sort, hopefully a lower level NEPA review that will, for any specific deployment, where there would have to be a confirmation that that reactor and those parameters of that reactor would fall within the PPE that's been previously developed. That review, that confirmation would likely be a lower level document, maybe an EA or something, a supplement analysis of some sort. Next slide. There are limitations, of course, with this approach. Dave touched on them. Some of the parameters are not known by vendors at this design stage. We sent out some questionnaires to vendors, and they provided a lot of information back for our use, which was very good. But not every design has progressed to the point where the important parameters for an environmental assessment are known. So in these cases, we did estimate as many as possible using our professional knowledge, our past experience doing environmental impact statements for NRC and for other EISs. But knowing what these values are from a vendor is going to be very important. And at this stage, they're just not known. And that's another thing that Dave mentioned is sometimes when we knew that there's a regulatory limit that was not going to be exceeded, that is an obvious way to think about a plant parameter as a bounding value. There's some regulatory issues that are not fully resolved. Some of these very small reactors are proposing a very small EPZ as an example, and those are still being reviewed and considered by NRC. Another impact that is hard to pin down at this point is the timing of the impacts. Timing is also very important, and if you consider that a reactor may be, or a design may have multiple modules, and that those modules may be deployed over time, the timing of the impacts may not be known. For instance, NuScale has a design that has multiple modules, and they may develop the infrastructure for the total number of modules, but they may not deploy any specific number of modules. At the start, they may deploy those over time. And those may not be known. So the timing of the impacts may be difficult to determine. Dave mentioned the problem with the fission product inventories. The releases, routine releases and accidental releases are one of the key assessments that need to be made for a environmental assessment. And that is the type of information that may not be known. Either the release mechanisms, the accident scenarios, or the fission product inventories that could be released over time. And lastly, there, as I mentioned in this last slide, you would have a DOE review of an EIS that would be done, or an NRC review of an EIS that would be done for a PPE for a surrogate reactor, but that wouldn't completely eliminate the need for a subsequent review just to confirm that a specific design fit within that PPE. Next slide. Pass this back to Dave.
Thanks, Bruce. So subsequent to us publishing the NRIC PPE report, we began to think a little bit more about the various licensing and authorization pathways for an advanced reactor. Certain reactor deployments will require NRC licensing. Others may only require DOE authorization. Another plug for another product that we've developed and is also available on the NRIC website under the resources is we've published this draft roadmap report that contains this flowchart slide that's on the screen. And there are specific numbers in here, and those correspond to the sections in our roadmap document where the relevant discussion associated with this issue or piece could be found. So the next few slides of this presentation lay out some of the details as to licensing versus authorization. So regarding the roadmap, really the biggest decision point is broadly, and I'm sure there are exceptions that we haven't even considered at this point, but really broadly, whether the reactor is going to be selling power commercially. And our big assumption here is that a reactor is either going to require an NRC license or be authorized by DOE, but it's not going to require both. That said, and I'll get into this in the next slide, but if the NRC licensed reactor is going to be sited at a DOE site, it's going to need some level of DOE approval to use that site. So very broadly, NRC licensing is required if the proposed reactor will be operated as part of the power generation facilities of an electric utility system, or operated in any other manner for the purpose of demonstrating the suitability for commercial application of such a reactor. And on the other hand, DOE authorization is required for testing of reactor concepts. And again, our assumption here is that both would not be required. So we've seen a lot of potential interest in setting an NRC licensed reactor at a DOE facility. This would involve the cooperation and input of both NRC and DOE. And while an NRC license would be required, the DOE site would also need to determine site suitability. And this would require some level of DOE specific NEPA analysis. It's not DOE authorization, but it is DOE approval to use the site in question. This may be a DOE site use permit or some other form of compliance. So if the reactor design is not known, but the DOE site or an applicant is interested in getting site coverage, the NRC ESP or early site permit may be the appropriate mechanism. And in that, we believe that both NRC and DOE could work as cooperating agencies on an EIS or multiple EISs that would cover both agencies' needs. I think our preferred approach hasn't really been applied yet, but our preferred approach would be that NRC and DOE act as co-lead agencies on an early site permit EIS that would meet both the needs of the NRC licensing process, but also DOE's site suitability needs. If the reactor design is known, an early site permit would not be necessary, and instead, this would likely be a construction permit or a combined operating license. But again, this would require NRC licensing for the project and DOE approval of the site being proposed. And again, Dan and Laura are here to talk about the advanced reactor GEIS, but when completed, the advanced reactor GEIS could help with that process. For NRC licensing at non-DOE sites, that's pretty much just the standard NRC licensing approach that would be done under either Part 50 or Part 52. There would really be no role for DOE in the process. The potential for some expertise or some information to be provided, but DOE really wouldn't have a role in the process. And again, here, the NRC advanced reactor GEIS, when completed, could really the intent of it is that it would be used to streamline that NRC licensing process wherever that is proposed to be. So for DOE authorization, this is sort of the opposite of what I said before. The reactor must not be operated as part of the power generation facilities of an electric utility system or operated for the purpose of demonstrating the suitability for commercial application of such a reactor. So this is really where I think Bruce and I see the PPE coming into play and being the most applicable and relevant. So DOE authorization could be streamlined if the DOE site in question has already completed a NEPA review analyzing advanced reactor deployment. We see the NRIC PPE as being applicable as a surrogate, so we would carry that PPE into an EIS to support the generic NEPA analysis. If the DOE site has not completed previous site-specific NEPA and has not applied to PPE previously, then basically you would need to start from scratch. You would need to do a single comprehensive project-specific EIS analyzing both the reactor and site suitability all in one. So we see there being utility in if there's a desire for use of a DOE site for DOE authorization to start that process early and apply either the PPE that we've developed for Enric or a different PPE as a surrogate. So right now, Bruce and I are working with our team to identify information that an applicant would need to provide as part of either the NRC licensing application or a DOE authorization. NRC Regulatory Guide 4.2 is an excellent document, and it provides guidance to the applicant on what information needs to be included in an NRC licensing application to support the development of an EIS. And Dana is going to talk to this in a little bit, but as part of the development of the advanced reactor GEIS and associated rulemaking, that's currently being updated, and the proposal is to add a new appendix specific to advanced reactors, providing specific direction that is not applicable to, or is specifically applicable to advanced reactors that may not be applicable to large light water reactors. The assumption that Bruce and I are working on is that similar information to that required by NRC would be required for a DOE authorization. The best example of a DOE authorization that we have at this point is the Versatile Test Reactor Draft EIS, which was published earlier this year and provides us with some very relevant information on what information was carried forward into that analysis and what information was analyzed. So what we're doing right now is working on identifying commonalities and differences between the NRC and DOE requirements for these environmental reports or some DOE equivalent. Like I mentioned before, we've got this roadmap published in draft form as of June of this year, and it's again linked here and available on the Enric website. So I'm going to wrap this up for Bruce and I and then pass this over to NRC, but just a really broad overarching summary that we've sort of touched on here. The PPE is a set of reactor and owner engineered parameters associated with a suite of designs, and the site parameter envelope is a set of parameters associated with the environmental resource requirements associated with those designs. So combining the PPE with the SPE allows for environmental analysis of resource issues. The PPE and SPE itself, like Bruce said, is not an environmental analysis of the issues. It's something that could be carried forward as a surrogate to be analyzed in a NEPA analysis. So that combination, the PPE, SPE, can support generic environmental analysis without a specific project proposal if the parameters are well understood and consistent across projects. That is the goal and intent, and I think that is something that the NRC Advanced Reactor GEIS is doing and applying. And then, like I was just talking about, the appropriate permitting strategy depends on whether an NRC license or DOE authorization is required, and whether programmatic NEPA guidance, which would be either the NRC Advanced Reactor GEIS on the NRC side, or some sort of DOE document applying the PPE or SPE exists. So with that, thank you very much, and I will now pass it over to Dan Barnhurst.
Okay, all right, can you hear me?
Yep.
All right, great. Yeah, so it's been said, my name is Dan Barnhurst. I am part of the NRC project management team that's developing the Advanced Nuclear Reactor Generic Environmental Impact Statement. That's a mouthful. I think you've already heard Dave and Bruce refer to it as the ANR GEIS, and that's what I'll do throughout the presentation. So hopefully using that acronym isn't confusing, but that's how we've come to refer to it as we've been working on it this past year. Laura Willingham is the lead project manager. She's on our panel today and will help with any questions you have. And we're both members of the Nuclear Regulatory Commission's Environmental Center of Expertise. And we've also worked as subject matter experts in our respective technical areas on the GEIS. The intent today for the presentation is to be a high-level overview of how the NRC is using the plant and site parameter envelope approach that PNNL has just talked about so well to develop the ANR GEIS for use at the NRC by applicants for advanced nuclear reactors. One note though, because the GEIS is still in draft form and it's part of not only the NEPA process, but also our rulemaking process here at the NRC, it's not been released for public review and we're limited in the amount of detail that we can share at this time, but we'll be happy to answer as many questions as we can today. Just for your information, the GEIS is going to be ready for public release in May of next year. There'll be a number of public meetings at that time, and we're happy to go into great detail and have in-depth discussions and accept formal comments then as part of both the NEPA and the rulemaking process. So next slide, Dave. Appreciate that. So our goal in developing the ANR GEIS is to streamline the NRC environmental review process for advanced reactors by utilizing the PPE and SPE approach that's been discussed to identify the impacts that may result from construction, operation, decommissioning of advanced reactors. In addition, this GEIS is considering the impacts of fuel cycle and continued storage. Before I go a whole lot further in the presentation, I think it's important to share 3 quick background points that will help to frame our discussion today. I want to just touch briefly on the environmental review process at the NRC. I know that there's been an Enric seminar on that in the past that Melisha Sutton, who's part of our advanced reactor project management group, presented. I'll just briefly highlight that process for you. Also want to talk about the use of GICEs and the PPE and SPE approach at the NRC. So just quickly, the licensing process for the NRC is described in 10 CFR Parts 50 for construction permits and operating licenses, and Part 52 for combined operating licenses and ESPs. Both of those sections point to 10 CFR Part 51, which is where the requirements under the National Environmental Policy Act, or NEPA, where they are described in their application to the NRC and the NRC's licensing actions. And the NRC implementation of NEPA under 10 CFR Part 51 is pretty straightforward. An applicant will evaluate the expected environmental impacts and document this in an environmental report. We call it the ER, which is submitted to the NRC as part of the application. And this is per 10 CFR Part 51. 45. Then the NRC takes this ER, this environmental report, and other independent information and evaluations, and will prepare an EIS for the licensing, for the specific licensing action. The impact from, the impact from each issue is determined to fall in 3 impact categories, and I believe Dave mentioned this earlier, or Bruce. It was small, which is not noticeable or destabilizing; moderate, which is noticeable but not destabilizing; and large, which is noticeable and destabilizing. So that ANR GICE is focusing really on using PPE and SPE values and assumptions to support drawing generic impact conclusions for a suite of environmental issues in the small category. So what is a GICE? The staff have recognized that similar licensing actions, for example, the licensing of a new reactor, often have a number of common issues with similar environmental impacts. The staff has found that addressing these common issues up front in a generic EIS or a GICE is beneficial because the staff can avoid repeating the same analysis in subsequent project-specific EISs. And the benefit then is that those subsequent EISs, we call them CISs sometimes, can reference the GICE for the generic issues and then focus on providing an in-depth review and discussion on the complex and unique issues. The NRC currently uses GICEs for environmental reviews in a number of areas, and one of those is license renewal for operating reactors, and they're used in a couple of different areas as well. So lastly, the PPE and SPE approach, I believe this has been covered by PNNL when they mentioned Clinch River and PSEG, but we have used this in the past as part of our environmental reviews for the licensing review, the environmental review process as part of the licensing of these sites. So what I wanted to highlight here is just the fact that that we have experience using GICEs and the PPE approach in environmental reviews, but this effort right now, the development of the ANR GICE, is unique because we're using the plant and site parameter envelope approach to develop the framework for environmental assessment in a GICE, because neither the design nor the site has been specified. Again, the PPE parameters are meant to bound a range of advanced reactor designs and are not site dependent. SPE parameters, or the site parameter envelope, was developed to bound the site characteristics by developing values and assumptions related to the condition of the affected environment. The GICE uses the PPEs and SPEs to group the impacts of construction, operation, and decommissioning into 2 categories. One is category 1, and the category 1 issues are those that can be generically determined to result in a small impact. Again, small meaning not noticeable or destabilizing, if the applicable project and site parameters fit within the bounding PPE and SPE parameters, values, and assumptions which are developed by the staff. And then the second category is category 2. Now these are issues, environmental issues, that cannot be determined generically and will need to be addressed later in a project-specific supplemental EIS or SICE. Next slide, Dave. Let me take a sip. I just wanted to briefly highlight our approach in developing the ANR GICE. Our subject matter experts, or SMEs, first developed a list of potential environmental issues for each of the 16 resource areas that are evaluated in the GICE. So in these list of issues are issues within that resource area that may be impacted by construction, operation, or decommissioning of the reactor. To develop this list, the SMEs for each of the resource areas considered issues that have been evaluated in past GEISs or GEISs, such as the license renewal or the decommissioning or continued storage GEIS. So we use those to help us to develop this list. In addition, we also reviewed our the recent, I guess, the last 15 years or so, of reviews for operating in new reactor applications. We evaluated the issues that were applicable and that we evaluated in those licensing reviews, environmental reviews. And we made sure to evaluate and include those as part of the GEIS, as issues that were included as part of the GEIS. So, pardon me, overall the staff identified 121 potential environmental issues spread among those 16 environmental resource areas that we address in the GEIS. And here on the slide, we provide just a few examples of those 16 resource areas. Like land use, water use, visual ecology, socioeconomics is one, noise, and I won't continue to read that, but just to give you a feel for the different areas that we typically evaluate in our environmental impact statements that were included also in the GEIS. So with that list of 121 specific issues, then we moved on and we worked to develop a set of PPE and SPE parameters associated with their associated values and assumptions that we would use to bound the range of advanced reactor designs and site characteristics that be associated with potential projects, and that would help us to categorize and to support the categorization of the impacts for environmental issues. We developed 40 of these. So I just wanted to give you an example of PPE parameters. A plant parameter that we consider in the ANR GEIS, an example would be, say, the plant footprint size, the building height, or Phil Meyer talked about in the Enric PPE that was developed by PNNL, talked about water consumption. We considered in the ANR GEIS water demand, total water demand. So then a site parameter envelope value considered in the GEIS then would be site size, water availability. So what is available from a hydrological perspective there at the site to supply the total water demand that we defined in the PPE. Proximity to wetlands is another SPE, and again, there's more, 40 in total. And so now we've talked about development of the 121 specific environmental issues among the different resource areas and the PPE and SPE parameters. So for each environmental issue, the subject matter experts determined whether it would be possible to identify from that set of PPE and SPE values and assumptions, ones that might effectively bound a meaningful generic analysis and support a conclusion of small impact, which we deemed a Category 1 designation. And in a later slide, I'll provide an example of how this was done for one resource area. And just to give you a feeling for what our findings were in the GEIS, or what they are to this point, since the GEIS is still in draft form, we felt that calling upon the PPE and the SPE parameters, values, and assumptions, that 100 of the 121 environmental issues could be deemed a Category 1 issues. And 19 of them are Category 2 issues, meaning that they would need to be addressed on a project-specific basis for an impact to be reached. Now, I just want to be clear, that doesn't mean that these would be, these Category 2 issues would be above a small impact. It just means that we could not determine what the impact would be, whether small, moderate, or large, without actually looking at plant or site. We call it project-specific details. And then you've done the math and you've come up with 119 issues. There were 2 additional issues, actually. And for these dealt with electromagnetic field effects. For those, there wasn't a consensus in the scientific community for a conclusion to be reached. And so they're outliers in a bit. But I think the main thing we wanted to convey on this is just that out of those 121 issues that we identified needed to be involved, evaluated as part of an environmental impact statement, or typically had been, we could generically disposition 100 of those using the PPE and SPE parameters. So on the next slide, I just want to talk about how the PPE and SPE parameters were developed. Dave and Bruce and company at PNNL talked about the development of those as it related to the NRIC PPE report that PNNL had developed. Just wanted to give you a feel. We used a lot of the same resources independently as we developed ours, but I wanted to highlight just a couple of those. These PPE and SPE values and assumptions. First of all, I just want to point out the fact that how they're defined affect the amount of issues that the guys could address generically. And so we recognized at the outset it was very important to pay special attention to the development of these and to the constraint of the PPE and SP values and assumptions. And in the guys, there is a table that not only discusses these, but also the methodology behind these to provide more information and understanding as you're going through the different PPE and SP parameters. These were developed by a team of subject matter experts that consisted of both NRC technical area experts and contractor staff. And the list on the slides provides some examples. So there's 5 sub-bullets. I really just want to highlight 2 of these right now, not because they're more important, but I just wanted to draw these out a bit. One of them is just that we paid special attention and evaluated previous NRC generic EISs and new reactor EISs. And we did this to help staff understand the factors which have historically contributed to greater than small impacts. And when we looked at any potential issue in a resource area that was driving a greater than small impact in a previous EIS, that helped us to understand and better define our issues and the PPEs and SPEs, but also as part of the PPE and SPE, develop the range that we felt could constrain that potential impact so that it could be defensively small. So we drew on past experience. We also evaluated EIS's reports and environmental analyses from other federal agencies. And this includes the NRIC PPE report that Dave mentioned earlier. We used it to inform PPEs where it was applicable, but it contained a survey of potential vendors. And I will say specifically, as Phil Meyer talked about, water use, water demand. That was one thing that, as we considered the PPE for water demand in the ANR guys, we were able to look at that and at least have an understanding of what the vendors that responded to the survey anticipated as part of water, the water demand of the different plants. And so our PPE in the ANR guys is for total plant water demand, and it in part drew upon that. Again, the goal of the subject matter experts was to ensure that the PPEs and SPEs were broad enough to encompass a maximum amount of designs and sites, but specific enough that the impact findings would be defensible. And so there's a bit of a balance there that we recognized, and it was a challenge for us. Next slide, please. So we cannot and won't, don't have the time for it and can't run through the full list of PPE and SPEs as part of this presentation. I'll mention that that the NRC holds, I believe, monthly stakeholder meetings, which are public meetings with advanced nuclear reactor potential applicants. And in one of those recently, we presented the full list. And if you can see at the bottom of the slide, there's a session number, it's an ML number. If you, and I'm sorry that it's so small, but if you can see that number, if you search on that, that will bring up the full list of PPE and SPE values that were developed for the ANR guys. So this is just one example. And if you look on the left side, the environmental issue, the resource area is air quality. And in the resource area of air quality, the issue, which is one of the 121 issues that we developed, is emissions of criteria pollutants and dust during construction. So in order to to develop this as a category 1 or small impact, we drew on the following PPE and SPE values and parameters, values, and assumptions. And so there's a list of 5 there. Site size and location is 1. Permanent and temporary footprint of disturbance. Offsite rights of way. You can see those in the middle column there. And now you'll see off to the right, there are values and assumptions associated with each PPE and SPE that this environmental issue that needed to be met so that this environmental issue could be defensively categorized as a category 1 issue, meaning that we could reach a generic small impact if those PPE and SPE values were reached. So just as an example, site size and location, you can see the value and assumption associated with that. The assumption is that the site size is 100 acres or less. And then under that, the site is not located within 1 mile of a mandatory class 1 federal area where visibility is an important value. Again, this was done for each of the 100 category 1 issues. Next slide, please. Okay, so implementation. This is our last slide. And so I'll try to be brief. We envision that the GEIS would be implemented by an applicant and the NRC staff in the following ways. An advanced reactor applicant may incorporate the GEIS findings for particular category 1 environmental issues in their environmental report. To do this, the applicant would first demonstrate that the proposed project meets the relevant PPE and SPE values and assumptions related to each category 1 issue. And so I provided an example of that for the 1 issue on the previous slide. But also importantly is that that there needs to be the applicant needs to have a process in place to determine whether or not there's new and significant information. So a project would not need to meet the assumptions and parameters for all the resource area issues in order to use the GEIS, but can incorporate by reference the issues for which the proposed project meets the PPE and SPE values and assumptions. An application would then evaluate the category 1 issues that do not meet the PPE and SPE values and assumptions, along with any applicable category 2 issues. In addition, if the design of the project is such that an environmental issue is not applicable, then the applicant does not need to analyze the issue. An example of this is if the A&R design doesn't use cooling water, the impact issues associated with the use of cooling water do not need to be analyzed. However, I'll say that the applicant must briefly describe its basis for concluding that the issues are not applicable. So that is what applicants would do. Now, the NRC staff then will review the application and verify that the relevant PPE and SPE values and assumptions for the referenced environmental issues were met. And then the staff will review the applicant's new and significant process. The staff will develop a supplemental EIS that focuses on the category 2 issues, which are the project-specific issues, and the category 1 issues that were not bounded by the GEIS. The supplemental EIS would incorporate the findings of the A&R GEIS for the category 1 environmental issues that the staff verified meet the PPE and SPE values and assumptions. I'll also note that the NRC has issued guidance relative to the environmental process. Dave talked about that guidance in the PNNL presentation. Applicants and guidance to the applicants are found in regulatory guides, and specifically the environmental process guidance for the applicant in developing environmental reports is included in Regulatory Guide 4.2. Staff guidance on preparing an EIS is issued in new regs. And so as part of the A&R GEIS process, we recognized that we needed to include that information in both guidance to the applicants and staff. And so currently as part of the rulemaking process, Regulatory Guide 4.2 is being updated and Appendix C is being added, which addresses how an applicant might address the category 1 issues in their environmental report. And then the staff guidance, we're developing an interim staff guidance for an ISG that discusses this. The last point I wanted to make, and I guess I've already said this, but the GEIS is undergoing rulemaking, and the commission has directed the staff to codify the findings of the GEIS into 10 CFR 51, similar to what was done for the license renewal GEIS. And so with that, that is the end of my overview for the ANR guys and where we are now. And just we'll mention again that we'll be totally open for public comment and review and presentation of our results in May of next year.
Thanks, Dan. Unfortunately, we ran out of time for our Q&A. As you can tell, we had a lot of ground to cover, but I wanted to thank today's speakers for taking the time to present on the topic. And I also like to thank the audience for your participation. As a reminder, slides will be posted to the Enric website. And if you have any questions at all, please contact us at enric@inl.gov. We will be addressing anyone's questions and sending it back to you in a timely manner. This concludes today's Tech Talk. Have a wonderful day.